Hello, this is Vic Tantry at Canjo.com. In this video, I'm going to show you how to use a loan amortization schedule to determine your payments over the lifetime of a fixed-rate loan. This spreadsheet was created by Dr. Vitver at Vertex42.com. Vertex42 is a wonderful online resource featuring dozens of different spreadsheets, many of which are available for free and some of which are available for a paid download. I highly recommend you check them out. Let's get started by looking at some of the input fields. The first major input field is in cell D5, the loan amount. The loan amount is simply how much you are borrowing up front. In this particular situation, we're going to be borrowing $250,000. Like everything else in this spreadsheet, this number can be customized based on the specifics of your loan. Next up, in cell D6, we have the annual interest rate. This represents the rate at which we are borrowing the money. We're going to assume 6% per year. Next up, we have the term of loan in years. The term of loan in years represents how long we're planning on taking to repay the loan. A lot of mortgages are repaid on a 15-year or 30-year basis. But again, depending on the type of loan and the purpose of the loan, this number can be customized. We're going to assume a 15-year loan. The next field is the first payment date. This is the date that you start paying off the loan. Now, I'm borrowing the money in August of 2009. So my first payment is going to be on September 1st, 2009. So in this field, I input 9-1-2009. Next up, we have the payment frequency. The payment frequency represents how often we are making payments. As you can see in this drop-down menu, payments can be made as infrequently as annually or as frequently as weekly. Most mortgages in the United States are paid on a monthly basis, and that's what we're going to assume here as well. Next up, we have the compound period. The compound period is not something that you normally get to choose in your loan. It's determined by the specifics of the agreement. Most compound periods for mortgages in the United States are on a monthly basis, while Canadian mortgages are compounded on a semi-annual basis. Once again, the drop-down menu here allows you to choose the specifics. We're going to assume a monthly compounding period. Finally, we have the payment type. The payment type is also something that's not normally determined by you, but more by the specifics of the loan. If you don't know the specifics of the payment type, just assume that you're making payments at the end of the period. In this situation, that would be the end of the month. However, if you do know that you're making payments at the beginning of the period, this gives you the option to make that change with the drop-down menu. We're going to assume end of period for now. So now that we have all our input fields, we can start looking at some of the outputs. The first major output is in cell D13, the monthly payment. As you can see in this loan, the monthly payment will be $2,109.64. Moving up here to the summary sheet, we can see that the first major field is the rate per period. By the way, just on a quick side note, if you take a look at these little red arrows in the corner of the spreadsheet, they'll give you a little bit of helpful information on what this term actually means. So that's just another nice little piece of the spreadsheet in the way that it's been designed. Going back to the rate per period, this number represents how much we are paying on a periodical basis. So remember, we have periods that are a month long, and we are assuming an annual interest rate of 6%. So 6 divided by 12 is 0.5% per period. Next up, we have the number of payments. The number of payments represents how many total payments are we going to be making over the lifetime of the loan. We're going to be making 180 monthly payments in this situation. Right below that, we have two major categories. The total payment amount, which is how much total money we're repaying over the lifetime of the loan. And of that, how much is interest? So the total payments are going to be $379,000, and the total interest is going to be $129,000 of that. Remember, we have principal, the loan amount, of $250,000. Finally, there's a little box down here called estimated interest savings. This box right now doesn't really represent anything, but I'm going to come back to a little bit later. Let's now move down to the amortization schedule. Scrolling down here, we can look and see, first of all, in cell A18, we have the payment number. So this is payment number 1, which is going to be due on 9-1-2009, September 1st of 2009. Next is the payment amount, $2,109.64. The next column represents the additional payments. I'm going to come back to this in a second, but let's move on for now. Next up, we have the interest and the principal. So you can see how our payment is divided between principal and interest. And finally, we have the balance. The balance represents how much outstanding loan we still have after making this particular payment. As you can see, as we go down the loan here, the balance continues decreasing over time. The amount that we're dedicating to paying off principal continues to rise, and the amount dedicated to paying off interest continues to decline. These are all common characteristics within a loan, because as we start paying off principal, our interest exposure also goes down, so we can pay off the principal at a faster and faster rate. I'd now like to move on to the additional payments. Let's say that in 12 months we get a really big bonus, $10,000, and we say, hey, we have all this outstanding debt. We'd really like to pay some of this off right now. So in 12 months, I make an additional payment of $10,000, and this spreadsheet will now allow me to see the results of this $10,000 payment. So I click enter, and you can see that some of these numbers change, but let's actually scroll back up and look at the summary sheet. If you look at the summary sheet now, the number of payments has reduced from 180 to 170. The total payments has decreased from 379,000 to 367,000, and the total interest has also gone down. Now you see that this estimated interest savings box has suddenly jumped up to about $12,000. So by making that payment of $10,000 in month 12, we're going to be saving interest of $12,559.14 over the course of the loan. So this additional payments column is really useful to helping us understand how much we can save by making different additional payments at different times. The spreadsheet is very flexible in that sense. So now that we understand the fundamentals of how the spreadsheet works, I just want to point out a couple of other little neat features here. The first is this little rounding button. The rounding button allows you to customize a certain level of precision. If you click rounding on, it will round all the numbers to the nearest 2 decimal places. But if you get rid of that checkbox, it will make the numbers extremely precise, which is something that a lot of online calculators don't do. So this can really help you identify the exact cash flows of your loan. Finally, I'd like to show you the printing capacities of this spreadsheet. If you go up to the print preview here, this spreadsheet is very printer friendly. You can scroll down and you see that we have a summary sheet right at the top, and the whole amortization schedule is right below, and it fits nicely onto several pages with no outstanding numbers, and it's a very clean looking interface that you can print out and share with whomever you'd like. So that is the conclusion of this video, and I really hope that this video has helped you understand how to use the loan amortization schedule. To purchase this spreadsheet, I recommend that you click on the link in this video or visit my website, www.canjo.com. You can also go to Vertex42.com for information on additional spreadsheets and this spreadsheet as well. Thank you very much for watching, and for similar videos, please check out my website, www.canjo.com.